Hello everybody, this is 10.3 missing angles. So we're still doing right triangle trig, SOHCAHTOA, all that stuff. But today we're going to be doing some problems where we need to find an angle. If we're given two sides and want to find an angle, we are going to use trig. But before we get too far into that, let's solve for x. Here are three examples, A, B, and C. Pause and see if you can come up with what x is. All right, you may say, well, this is super easy. Here I'm going to divide both sides by 2, okay? So one way you can think of this is we're doing 2 times x. Well, what's the opposite of multiplication? Well, that would be division. So we would divide both sides by 2. That's like an inverse. The operation inverse for multiplication is division. All right, here's another example where we're doing x plus 2 equals 4. So what's the opposite of addition? Well, that would be subtraction. Okay, and we get x equals 2. All right, here's another example where we have x squared equals 4. So if we want to get x by itself, what's the inverse for squaring? Well, that's a square root. The opposite of squaring is a square root. So we get x equals 2, or if we take the principal square root. All right, so all of these, we have like these opposites or inverses. So let's look at this problem. I made a big mistake, well, not a big mistake, but I did 10 over 8, and it should be like 8 over 10. And I think we kind of talked about that perhaps in a previous video, is that the ratios for sine and cosine, that ratio is always less than 1. And I wrote it down when I was doing my notes, but when I typed it in, I put it in opposite. So forgive me for that, all right? So just like the other problems where we wanted to solve for x, here we want to solve for theta, okay? X, theta, they're both variables. We could use x for theta. Just typically, theta is used for degrees. All right, so we want to solve for this. Well, you may want to look at that and you'd say, well, it kind of looks like it's being multiplied, so maybe we could divide both sides by sine. Okay, but that is not multiplication. It's actually like a function. Like when we talked about function notation, f of x is equal to some sort of equation. F of x is a function. It's not being multiplied by x. The same thing here is sine of theta isn't sine times theta, all right? It's a function where we plug in theta and it gives you something, all right? So we can't divide both sides by sine. We can't subtract by both sides. Like we couldn't subtract f to both sides to get x by itself, okay? So it's too bad there isn't an opposite function that could cancel out a sine, or something that could cancel out a cosine, or could, like the inverse of tangent. Well, let's look at a calculator, okay? So if you look at your calculator, most likely you have buttons for sine, cosine, and tangent. Those are right over there. And what do you notice right above those? Well, I see, it's kind of hard to see, but on your calculator it's probably more easy to see, but it says sine with like an exponent kind of thing that's a -1. All right, so that is, if we use that, like wrote that in words, that's called the sine inverse. It's the opposite of sine. It cancels out a sine. All right, so if we want to get theta by itself, what we would need to do is we would do sine inverse for both sides. I kind of messed that up. Let me erase that part off. Okay, so we would do sine inverse. So what does sine inverse and sine do? Well, they are their inverse, so they cancel out. All right, and that just leaves us with theta. Theta is equal to sine inverse of 8/10. And you can plug that into your calculator and you'd get your answer. So let me grab that on mine. Okay, and I end up getting 53.13 degrees. All right, so please round your answers to like the hundredths place. I think typically it will say what to round to, either the hundredths place or tenths place, so 1 or 2 decimals. All right, so that's our answer. One thing you also need to make sure is that your calculator is set up to do degrees. So there's two, just like temperature, there's different units for temperature. You could do Celsius, Fahrenheit, Kelvin, Rankine. So there's like 4 different ways to measure temperature, at least 4 that I know of. The same with like degrees. We have degrees and we also have radians. So oftentimes these calculators will be automatically set to radians. So like a circle, for a circle it's 180 degrees. In radians, it is 2 pi radians. Okay, so those are like equivalent, just different units. All right, so to do that on your calculator, like for mine, I think I go to mode. And then if you go down, you'll see radians, and I need to push over and push enter, and then that will mark it as degrees. If you're using a different calculator, you may will see it differently. Casio's, typically you need to like do shift, and then there's like the mode or a setup that you'll need to click on. All right. All right, so hopefully when you plug that in, that gave you 53.13 degrees. All right, so we talked about inverses. So in our last class, we talked about SOHCAHTOA, sine theta is equal to opposite over hypotenuse. So again, if we want to get rid of that sine, we need to do its inverse. And the sine and the sine and sine inverse would cancel out, and that just leaves us with this. Okay? Sometimes I put parentheses around that. Sometimes not, but on your calculator it will put that. So here we got cosine inverse, that cancels out, but you got to do it to both sides. So we get theta is equal to cosine inverse of adjacent over a hypotenuse. And then tangent, again, same thing, tangent inverse to both sides. And the tangent inverse and the tangent would cancel, and that just leaves us with theta is equal to tangent inverse, opposite over adjacent. All right, so we're going to use those in this inverse trig to solve for an angle. All right, let's give a try on that. So again, we always want to still label our sides. So that's our reference angles. This is opposite, this is adjacent, and this is our hypotenuse. So what is given? We have our opposite and adjacent. So that's going to be like tangent theta is equal to opposite over adjacent. So we still want to remember SOHCAHTOA. Here we got OA, so that's tangent, SOHCAHTOA. All right, so we'll plug all that in. We get tangent of theta is equal to opposite over adjacent. And then we need to solve for theta. So we'll do tangent inverse on both sides, and we'd get theta is equal to tan inverse 9 over 7.4. We'd just get our calculator, we'd type all that in, and we get theta is approximately equal to 50.57 degrees. Again, if we are going to be if we're rounding, then theta isn't equal to, it's approximately equal to. So that's a good practice to do that. All right? Okay, so as we get a little longer on, we won't need to show all of that work. All right, why don't we give you an example? Actually, give this one a try. Pause this and try and do the same similar thing. All right, so here we have our reference angle. We have our hypotenuse and our adjacent. So what uses adjacent and hypotenuse? Well, that would be ka in SOHCAHTOA. So cosine theta is equal to adjacent over hypotenuse. And then we need to get theta by itself. So again, we could do cosine inverse on both sides. Again, we probably won't do that every time, but we're just making sure we understand where this is coming from. And we end up getting theta is approximately equal to 71.79 degrees. And again, you just have to plug that into your calculator. Make sure it's in degrees. All right, so let's do these a little quicker now. We got kind of know what's going on. So here we have our reference angle we're trying to find. Okay, we have our hypotenuse and adjacent. Same SOHCAHTOA. So we'll do, at this point I'm okay if you just do theta is equal to cosine inverse of adjacent over hypotenuse, so 20 over 24. Okay, so you can basically go straight from what we have up here and plug in those sides. All right, so here we'd end up getting theta is approximately equal to 33.56 degrees. All right, so we're almost there. This one's kind of a shorter lesson because we're doing Aspire testing during this week. So pause and give these ones a try, see what you come up with, and if you feel like you're good, then just go on and do your homework. All right, so here we've got our reference angle. We have opposite and hypotenuse, so that's SO. We'll do theta is equal to sine inverse of opposite over hypotenuse, which is 53. Sorry, I need to work on this so it's not so blurry. So theta is equal to, or approximately equal to, 21.01 degrees. All right, two more. Here we have hypotenuse and adjacent. So that's ka, or SOHCAHTOA. So we'll do theta equals cosine inverse adjacent over hypotenuse. It's 51 over 53. And we'll get theta is approximately equal to 15.79 degrees. All right, last example, we have opposite and adjacent. So that would be TOA, or SOHCAHTOA. And we would do theta is equal to tangent inverse of opposite over adjacent. And we get theta is approximately equal to 26.57 degrees. All right, well that's about it. So again, just remember that there is an opposite for sine, cosine, and tangent. Inverses is probably a better word. So that would be sine inverse, cosine inverse, and tangent inverse. And we can use those to find the missing angles of a right triangle trig. All right, we'll see you later.